Okay, so we are going to consider another question on trigonometry, which is question number 5. Simplify the following expression. That is the first part and so on. So that is 14 marks, which is actually something that is direct. If you do understand your basics, this type of a question was not going to be that much, but we need those basics. All right. So 5.1, we are given, simplify the following expression given the sine of 180 minus theta times the cos of 360 degrees minus theta over tan 180 degrees minus theta. So these typical questions are best that you do apply your quadrants. Remember from the cast concept, okay, from your angles, if this is theta, this is gonna be 180 degrees minus theta. This will be 180 degrees plus theta, 360 degrees minus theta. Remember when I talked about the issue of the reference angles concept. And this we know from the cast concept that you can consider the quadrant that you're given in each part in terms of theta. If it is the sine of 180 minus theta, it is just going to be equal to the sine of theta. This one will be equal to the tan of theta, will be positive. This one will be equal to the cos of theta, will be positive. So this is what we just need. All right. So we are given 5.1 sine 180 minus theta. 180 minus theta, the second quadrant, and this is equivalent to the sine of theta as an acute angle, times the cos of 360 degrees minus theta. 360 minus theta is the fourth quadrant, which is equivalent to the cosine of theta as a positive. All right, then we've got the tan of 180 degrees minus theta. If you consider that it's a 180 minus, where there is 180 minus theta is the quadrant for sine. This is the quadrant of sine. So it means tan, in this case, it will be a negative. Cos will be a negative. This is just for sine. This quadrant, it's only sine which will be positive. So tan is going to be a negative. Cos is going to be a negative. So this tan 180 minus that, because of the quadrant where it is going to be taken as a negative because that quadrant is not for tan. If it was tan 180 degrees plus theta like this, this is the one that was going to give us a tan theta. So you must be careful on your simplifications. All right, so this is it, guys. As we can see, this part, it seems like you cannot simplify further the way that it is. It seems like you're done. No. Remember, you are dividing. Let's consider to say this is the product, sine and cos. There's nothing that we can do. This is just the product. Just gonna maybe write sine theta, cos theta like this. But it is being divided to the tan of theta, dividing, like we are saying, it is same as 1 over a. When multiplied to b, you write this as b over a. So you can separate this to be b times 1 over a. So the moment that you are given a consideration of this nature, you can just multiply it times 1 over. Remember, you're dividing. So instead of you going back to that issue of I'm going to have a division, you can multiply. But anyways, you are dividing. You are dividing to what? The minus tan theta. If you do understand this, it's up to you guys. It's up to you. All right. But we know that the sine, the tan of theta that we are given here, we've got minus tan theta, remember? That we are dividing. It's like divided to. It is the same as sine theta over cos theta whenever you are given a tan. So meaning to say, you are simply having minus sine theta over cos theta. There is a division. So how do we go about it? Whenever you're given a division, we introduce a multiplication. The moment you introduce a multiplication, you're supposed to tip over the second for to interchange. So it is going to be minus cos theta over sine theta. You interchange that. And this is same as over 1. So it gives us the power to cancel the sine and the sine together. And thus, at the end, what are we going to have? Cos theta times minus cos theta is minus cos squared theta. Cos terms, just like x times x, x squared. So a cos and a cos will be a cos squared theta. That's a single term that you can have. So as long you are given, as long you understand your quadrants, you can simplify this direct. All right, so 5.2, it was to simplify or to determine the value of the following with the use of a calculator. The calculator is supposed to, all right. So remember, I talked about this, that when you're given the radians, the pi, it means these are radians. You can convert this to degrees. All right. Pi is just same as 180 degrees whenever you're given a pi. So pi over 6, it means 180 degrees over 6, which is going to be 30 degrees. Remember, there's a squared. So it's same as we've got 2 sine 30 degrees, but everything being squared. The sine squared 30 degrees is the same as sine 30 in a bracket squared. You square the whole of the trig. Okay? Plus cos 30. That is cos 90, sorry, plus cos 90 there, cos 90 degrees. There's a need for us to simplify some other things here. We've got the cube root of sec 60 degrees. Remember, sec x is given as 1 over cos x. So if it is sec 6 degrees, it's going to be 1 over cos 60 degrees. So that's we've got minus the cube root of 1 over the sec 60 is the same as the cos of 60 degrees minus 1,5. All right, so if you do understand this and you do not want to indicate, it's up to you. You can just use your calculator straightforward. All right, so you can even simplify each stage by stage. It's up to you guys. So everything is in degrees, so there's no need for me to change my calculator to radians because this is in degrees, so it's going to be 2 sine. The calculator opened a bracket. All right, we're supposed to have our on here, the bracket. Remember, it's 2 open bracket. Then there's a sine. The calculator opened its own bracket, close that of a calculator, then you close the one that you opened before, square this. So that's 1 over 2. So we've got 1 over 2 plus the cos of 90 degrees. So that is cos 90. This is going to be a 0 minus, we simplify this, that is going to be the cube root. So the cube root, we need the shift, the cube root where there's a square root here. On top, there's a cube root. So that's the cube root of 1 over cos 60 degrees. All right. Let's close the bracket, then move aside, minus 1,5. So that is going to be 0,7 and so on and so on. So this is actually a decimal, cannot be written as a fraction, as you can see. So you can even fix this to 3 decimal places. That is press 3, it's going to be 0,794. So that's we've got 0,794. So that is you and your calculator there. Simplify 1 over 2 plus a 0 minus this. That's simply 1 over 2 minus 0,794. All right. So that will be negative 0,294, negative 0,294 to 3 decimal places. So these are the typical questions that you might be given actually, where we're just using a calculator. I talked about this before in other previous questions. So let's revise as much questions as we can. Convert pi over 2 from radians to degrees and minutes. All right, this is supposed to be just degrees, but they need the answer in degrees and minutes. Remember, I talked about the pi being equal to 180 degrees. So when you're given pi over 32, it means you're supposed to divide. All right, so this is what you're supposed to have on your calculator. I just want you to see what you were going to have if you had to divide, because you divide, you remove the pi, is 180 degrees. So that is 180 degrees divided by 32 like this. So it was gonna be 5,625. So the 5 there is representing the full angle, like 5,625, 5,625 degrees. So that's, we have got the whole number representing the 5 degrees. Then the 0,625 is representing the remainder in degrees. That's a remainder in degrees. So this remainder, this one, is the one that you convert to minutes, because the answer is needed in degrees and minutes. So you've got 5 degrees and this remainder of 0,625. How do you convert this to minutes? A degree is equal to 60 minutes. So what about 0,25? I just have to multiply by 60 to convert to minutes. That's 0,25, 0,625 times 60, the remainder of the decimal that you're given. So that was going to be 37,5. As you can see, that is going to be 37,5 minutes. So this is 37,5 minutes, which you can write again in minutes and seconds, but there we just need minutes. So minutes, so you're going to have 5 degrees and 37,5 minutes. So that is how you can present this, or you could have presented to minutes. Then you convert back, guys. It will be, you're now working, you're just a repetition. So instead of that, just straightforward. These are degrees. Pi can be written in degrees. Pi is in radians, so 2 degrees is 180. So by dividing by 32, you are obtaining the exact value. Determine all the values of theta in the following equation. If theta is an element from 0 to 360 within the interval from 0 to 360. All right, I talked about working the trigonometric equations. So that's why we've got 5 tan theta plus 8. All right, so that's 5.4. So let us just consider this 5.4. So there we are given 5 tan theta is 5 tan theta plus 8 is equal to, as here, and that is the theta being taken from 0 to 360 degrees. This is the interval that you're supposed to work with. So I say that whenever you're given this type of equation, work with the trig that you're given, the trig ratio, the tan. Is it the cos? Is it the tan? Obtain a single trig. That is, you have to make tan the subject. So how can we make tan the subject? There is 8 which is affecting, so you're going to transpose this. That will be 5. Tan theta is equal to minus 8. It was a positive. On the other hand, it will be a negative 0 minus 8. That's minus 8. 5 is multiplying, so to remove this 5, you're going to divide. So if you divide this, that's 5 divided by 5, that will be a 1. So that's tan of theta is equal to minus 8 over 5. So this is the case. This part that we are having in this case here, in order for us to have the theta, we must consider in terms of the quadrants. That's where our quadrants play a role. Remember, in the previous case, I was just writing theta. But now it is going to be like the theta is equal to the reference angle. We're going to talk about the reference angle theta equal to 180 degrees minus the reference angle. I talked about this part, theta being equal to 180 degrees plus the reference angle in the fourth quadrant, 360 degrees minus the reference angle. We do understand this. This is a tan that we are working with. So there is a need for us to obtain the reference angle. We're going to consider that the negative is for the quadrant. Remember from the cast concept, each and every quadrant is represented with a positive where it is situated. So the reference angle, you do not consider the sine. The sine, you use it when you are now considering the quadrants. So you just calculate the reference angle as if you are not given the sine. In this case, the sine is a negative. Yes. Just forget about that. So that is going to be arctan to find the reference angle, arctan 8/5. Ignore this negative. So you ignore the sine. So the reference angle being arctan of this in degrees, you were going to obtain 57,995 degrees to 3 decimal places. So the reference angle is not our answer. No, it is the one that you are going to use to determine the exact solution using our quadrants, using the idea of the quadrants. That is where the negative here plays a role. You're asking yourself, from this single trig, you work from the single trig that you're given. It is equal to a negative, a tan equal to a negative, not a positive. If it was a positive, we're going to take where tan is positive in the third and in the first. This is where we're going to take our answers. But it's the vice versa now, because this is where tan is a negative. So meaning to say the answers or the solutions will be in the other quadrants, the second and the fourth quadrant. This is where tan is negative. Remember, in the second, it is for sine. So it means tan there is a negative. In the fourth quadrant is for cos. So tan in this quadrant is a negative. So thus we can determine theta. So therefore our theta from the second quadrant, our theta is 180 degrees minus the reference angle. And this is our reference angle, 57,995 degrees, or our theta from the fourth quadrant, where tan is also a negative, theta is equal to 360 degrees minus the reference angle, which is 57,995 degrees. Thus, we are determining the exact values of theta, the actual values of theta. So this was going to be 122,005 degrees, or theta was going to be 302,005 degrees. Within the interval of 0 to 360 degrees, this is enough to obtain our solutions. So these were the two possible solutions within the interval that we are given from 0 to 360 degrees that will satisfy this. So these are the typical questions. Must be very, very careful how we're going to answer a trigonometric equation. All right, so these were all possible values within the interval. 5.2 you're given. AB is a vertical cliff. That's a vertical cliff. C is a point 380 meters from the cliff, which is the point C is 380 meters from the bottom of the cliff. The angle of elevation of the cliff is 58 degrees as we are given. Then calculate the height of the cliff. We talked about this same type of a question when you are being asked to calculate the height of the tree. It can be the height of the building, the height of the flagpole, whatever that you're given with the angle of elevation. There's something that we have from the angle of 58 degrees. AB, the side to be calculated, is the opposite. It faces the side that we are given. So thus we've got opposite. Remember, this is a vertical line meeting a horizontal line. These two, they meet at 90 degrees, meaning to say this side is the hypotenuse. You are not to focus with the side of AC. There's nothing that we want here. So you focus with what you are given and what you're supposed to calculate. Opposite, what is it that you're given? The adjacent. There is only one ratio that you can use. Remember, you have to calculate the side having an angle. So definitely they have to think of the trigonometrical ratios, the application of the SOHCAHTOA. Using the SOHCAHTOA concept, there's only one ratio that has got opposite and adjacent at the same time. There's only one ratio, opposite and adjacent at the same time. which is the ratio of tan. So the ratio of tan, it states that the tan of theta, which is the angle, is equal to the opposite over the adjacent. This is the ratio of a tan, where theta is the angle that you're given, which you used to determine these sides. You were focusing with 58 degrees. So that's your theta. The opposite side is AB, the side to be calculated. The adjacent side is the one that you're given, which is 380 meters. So with this ratio, you can calculate the height of the cliff, which is AB. So this is over 1, cross multiply both sides. So that's going to be 1 times AB, which is AB is equal to 380 times the tan of 58 degrees. So AB is equal to what? If you were to multiply this properly on your calculator, this was going to give you that was going to be 608.127 meters. So the height of the cliff is 608.127 meters. So this is how we can simplify these typical questions. If you are given a typical question of this nature, be careful. Apply your trigonometrical ratios. Sometimes they might give you this part and they want you to calculate this. There is only one ratio that you use. Is it for cos? Is it for sine? There is only one ratio. It's either for sine, it's either for cos, or is it for tan? It's a single ratio to be used. So these are the typical questions that you might have. More questions of these from Meson African Motives till we meet again.